Hello everyone, I am C. Nitya, working as Assistant Professor in ECE Department, R.M.K College of Engineering and Technology. I am handling the subject called Basics of Biomedical Instrumentation and the subject code is OMD 551. And welcome to the session. Today we are going to see about measurement of biomedical with two electrodes. This equivalent circuit represents measurement of biomedical with the two electrodes. We will see these descriptions. Here R1 and R3 represents resistance, whereas E1 and E2 are off-cell potential. Off-cell potential is defined as the voltage developed at an electrode and electrolyte interface. The next one is C1 and C2 that represents capacitance, whereas Z1 and Z2 we can call it as a skin contact impedance, where R is tissue resistance, R2 and R4 represents Faradic leakage resistance. Now we will get into the detail about the measurement of biopotential with the two electrodes. Generally, we know that electrodes are used to measure biopotentials. In this equivalent circuit of biopotential electrode is having contact with the body consists of the voltage in series with resistance and capacitance network. Since the measurement of the bioelectric potential requires two electrodes, the voltage measured is difference between the potential of these two electrodes. Here the voltage is represented as V in the previous circuit diagram. Here we are going to have the two types of measurements, that is if two electrodes are of same type, the difference of usually same. So if we take the measurement between the two electrodes, then the difference will be same and depends on the actual difference of the ionic potential between the 2 points of the body from which the measurement that we are going to take in. The next point is if the electrodes are all of different type. So then we will see they may produce the significant DC voltage that can cause current to flow through both the electrodes and also through the input circuit of the amplifier which they are connected. So here we are going to experience the voltage called electrode offset voltage, that is the DC voltage due to the difference in the electrode potentials. So we can call that potential as an electrode offset voltage. So even if the two electrodes are of the same material, this can produce a small electrode offset voltage. So next point is we are going to experience the term called voltage fluctuation that can appear as a noise on the bioelectric signal that are going to be recorded. This is mainly due to the chemical activity takes place within an electrode. And then we can also reduce this noise by choosing a material, that is a proper material, or by coating the electrode by some electrolytic method to improve the stability. So the best thing to improve the stability as well as to reduce the noise is we can use the silver chloride electrode, that is AgCl electrode. So this Ag and AgCl electrode is prepared by electrolytically by coating a silver, that is a pure silver, with an pure silver chloride. Now we will look into how the coating is done for the electrode. That is, this coating is done by placing a silver into a bromide free sodium chloride solution, and a second piece, that is another piece of the silver, is going to be placed in the solution in which two are connected with an voltage source in way that electrode to be chloride is made with a positive with respect to other. And then the silver ion combined with the chloride ion forms the salt to produce the neutral AgCl molecule that coat the Ag electrode. From the figure we can see the resistance and the capacitance network, which represents the impedance of the electrode as a fixed value of resistance and capacitance. Here unfortunately we are going to have a impedance which is not of a constant value. Impedance is frequently depends because of the effect of capacitance. Furthermore, both electrode potential and impedance are varied by the effect called polarization. This polarization is a result of direct current passing through the metal electrolyte interface. Some electrodes are designed in order to avoid or we can also reduce the polarization. From the figure, it shows that impedance of the electrode would be high in the low frequency region and it would be decreased with an increasing frequency. While measuring the bioelectric signals, it is important to minimize the potential drop across this electrode impedance. This is achieved by making the skin contact impedance as low as possible and make the input impedance of the measuring device as high as possible. So here size and type of electrodes also important in determining the electrode impedance. So larger electrode can have a lower impedance. So surface electrode have the impedance of about 2 to 10 kilo ohms here, whereas small needle electrodes and micro electrodes have much higher impedance. For the best result in reading or recording the potential measured by the electrodes, the input impedance of the amplifier must be several times of the electrode. And this is all about the measurement of biopotential using two electrodes. Hope you all enjoyed the session. Thank you.